What if I told you that one of the most shocking moments in pop culture history wasn't just a celebrity breakdown, but a scientifically predictable response written in DNA? February 16th, 2007. Britney Spears walks into a hair salon in California and shaves off all her hair in front of stunned witnesses. The world called it a meltdown. But modern artificial intelligence and genetic research reveals something far more extraordinary. Her genes had been preparing for this moment her entire life. Today, AI platforms like Sophia Genetics analyze over 2 million genomic profiles with 99% accuracy, identifying behavioral patterns invisible to the human eye. These algorithms process thousands of genetic variants simultaneously, creating what scientists call polygenic risk scores for impulsivity, depression, and trauma response. Had we possessed this technology in 2007, we could have predicted that Britney was genetically predisposed to an extreme response to chronic stress. But to understand what really happened that night, we need to go deeper into the science. When Britney picked up those clippers, her brain was undergoing measurable neurobiological changes. The chronic media pressure had literally restructured her neural pathways. The prefrontal cortex, responsible for impulse control, had shrunk. The amygdala, our threat detection center, had expanded. The hippocampus, crucial for stress regulation, was suffering atrophy. This wasn't madness. This was biology. Her own words, revealed years later in her memoir, confirm the scientific basis. "I don't want anyone touching me. I'm tired of everybody touching me." She described the moment as almost religious and explained, "Shaving my head was a way to say to the world, F you. You want me to be pretty for you? F you." This wasn't an impulsive random act. It was a genetically influenced behavioral response to multiple simultaneous stressors: divorce from Kevin Federline, a custody battle for her children, the death of her beloved Aunt Sandra, constant paparazzi pressure, and complete loss of personal autonomy. The science is breathtaking. The FKBP5 gene, present in varying forms across the population, determines how we respond to extreme trauma. When activated by childhood trauma or extreme stress, it literally alters genetic expression through epigenetic modifications, creating hypersensitivity to cortisol that can last decades. Recent studies with Syrian refugees identified 35 specific DNA positions that are modified by exposure to violence, and these modifications can be transmitted to future generations. Trauma literally rewrites our genetic code. Then there's the COMT gene, present in 80% of the population in some variant. It determines whether we're warriors or worriers, our ability to process neurotransmitters in the frontal cortex under pressure. People with the worrier variant show 58% more cortisol response during stress, especially women, and can have drastically reduced performance in high-pressure situations. Britney's specific genetic makeup made her particularly vulnerable to the exact type of relentless pressure she was experiencing. Even more fascinating is the MAOA gene, sensationalized as the warrior gene. It appears in 59% of African American men, 56% of Maori men, and 34% of Caucasian men. But here's the revolutionary discovery. This gene doesn't cause aggression directly. It only amplifies responses to extreme provocations when combined with childhood trauma. The interaction between genes and environment is everything. Paris Jackson, Michael Jackson's daughter, developed documented PTSD from paparazzi pressure. "I have auditory hallucinations sometimes with camera clicks and severe paranoia. I'll hear a trash bag rustling and panic." Her clinical assessment: "I think it's standard PTSD." She's not alone. Amanda Bynes shaved her head multiple times in 2013 during her own public breakdown, eventually being placed under psychiatric conservatorship. Kanye West was hospitalized for erratic behavior in 2016. Mariah Carey was hospitalized for exhaustion in 2001. These aren't random incidents. They're scientifically recognizable patterns. Research shows that individuals under constant surveillance develop social hypervigilance. The brain becomes hypersensitive to signs of social disapproval. A University of Sydney study showed that people under surveillance detect direct gazes almost a full second faster than controls, revealing how paparazzi pressure literally reprograms neural processing. The brain adapts to genuine threat by becoming hyperalert, creating the paranoia and avoidance behaviors we see in celebrities. The most shocking discovery of recent years is that traumatic experiences can permanently alter genetic expression. Studies with Holocaust survivors showed that extreme trauma causes changes in DNA methylation that are transmitted to children and grandchildren. The mechanism is fascinating. When exposed to extreme stress, genes like FKBP5 undergo decreased DNA methylation, causing them to be overexpressed. This creates an ultra-fast feedback loop in the hypothalamic pituitary adrenal axis, resulting in prolonged cortisol secretion and stress hypersensitivity. In the last 2 years, studies identified that approximately 70% of cortisol levels are hereditary, making them one of the most genetically influenced stress markers we know. This means Britney's ability to handle extreme pressure was partially programmed into her DNA from birth. The numbers behind behavioral genetics are cinematic. If all the DNA in your body were stretched out, it would reach 67 billion miles, more than 100 trips to the sun. We have 30 trillion cells, each containing 6 feet of DNA when unraveled. All the world's information in 2012 could be stored in just 4 grams of DNA. Yet humans are 99.9% genetically identical. All our diversity comes from just 0.1% difference. We share 96% of genes with primates, 70% with slugs, and 50% with bananas. And here's the kicker. 5 to 8% of human DNA is viral. We carry about 100,000 pieces of ancient retroviral DNA. Height is controlled by more than 12,000 DNA variants, not just one tall gene. There's no single music gene or wanderlust gene. Complex traits like impulsive behavior result from interactions between thousands of genetic variants plus environmental factors. And that's exactly what happened to Britney. When she shaved her head, statistics reveal she wasn't alone in her response pattern. 17% of all people self-harm at least once in their lifetime, with the average age of onset at 13. Among teenagers, this rate rises to 17%, and bisexual women have the highest rates at nearly 50%. Head shaving behavior fits perfectly within the scientific spectrum of self-control behaviors in response to trauma. Reclaiming autonomy when feeling powerless, sensory regulation by reducing excessive tactile input, identity reset through dramatic physical change, and nonverbal social signaling of distress. Technologies like Face2Gene now use AI to diagnose rare genetic conditions just by analyzing facial photographs, surpassing the accuracy of human specialists. Convolutional neural networks can identify behavioral signatures in genomic data that remained hidden for decades. 23andMe was authorized by the FDA to test 33 genetic variants related to drug metabolism, including genes that affect antidepressants and anxiolytics. Imagine if we had this technology in 2007. Research from 2025 identifies media-induced stress as a distinct environmental stressor that creates HPA axis dysregulation, blood-brain barrier compromise, and microglial activation. Celebrities under constant pressure show chronically elevated cortisol levels, systemic inflammation, and measurable brain structural changes. Being constantly photographed creates hyperactivation of social neural circuits, making individuals hypersensitive to signs of social disapproval. This explains why celebrities develop paranoia and avoidance behaviors. They're real neurobiological adaptations to a genuinely threatening environment. The most recent discoveries are stunning. A 2025 study with Syrian refugees documented for the first time in history intergenerational epigenetic signatures of violence in humans, scientifically proving that trauma creates biological changes that pass to children and grandchildren. Explainable AI technologies in genomics now provide not just predictions, but mechanical insights into how genetic variants interact to influence behavior. This represents a paradigm shift from black box models to real understanding of genetic processes. Studies show that teenagers with higher phone and social media use have greater cortisol awakening response and elevated IL-6 levels, an inflammatory marker. Social media pressure creates neurological changes similar to addictive substances, altering dopamine systems and creating tolerance that requires increasing stimulation. Britney's incident in 2007 represents much more than a celebrity breakdown. It was a documentable neurobiological response to multiple environmental stressors, influenced by measurable genetic factors and expressed through scientifically recognizable behavioral patterns. The convergence of behavioral genetics, trauma neuroscience, and AI technology reveals that seemingly irrational behaviors follow deep biological logic. Most importantly, this scientific understanding removes stigma and replaces moral judgment with factual biological analysis. Britney wasn't crazy. She was responding in a neurologically appropriate way to a genuinely toxic environment, using behavioral mechanisms documented by science as coping strategies and autonomy reclamation. Modern science offers us the tools to understand, predict, and potentially intervene early in similar situations. With advanced genetic analysis and understanding of gene-environment interactions, we can develop personalized support strategies that account for individual genetic vulnerabilities and specific environmental factors. The lasting legacy of Britney's moment shouldn't be entertainment or scandal, but a scientific window into how extreme trauma affects human brains and how we can use this knowledge to better protect vulnerable individuals in the future. Think about this. Every flash of a camera was triggering a cascade of neurochemical reactions in her brain. Every tabloid headline was literally altering her gene expression. The paparazzi weren't just documenting her breakdown. They were biologically engineering it. When she stood in that salon, electric clippers in hand, her DNA was screaming a message that took us 17 years to decode. The artificial intelligence systems analyzing genetic data today can see patterns that would take human researchers centuries to discover. They're finding connections between seemingly unrelated genes, revealing how a variant in one chromosome can amplify the effects of another on the opposite side of the genome. These discoveries are rewriting everything we thought we knew about human behavior. Consider this mind-blowing fact. If you took all the DNA from every human who ever lived and compressed it, it would fit in a space smaller than a sugar cube. Yet within that microscopic code lies the blueprint for every human response to trauma, every breakdown, every moment of resilience. Britney's story was written in a language we're only now learning to read. The implications are staggering. Insurance companies are already using genetic data to assess risk. Dating apps are incorporating DNA compatibility. Employers could theoretically screen for stress resilience genes. We're entering an era where your genetic code might determine not just your medical treatment, but your career path, your relationships, your entire life trajectory. But here's what really matters. Understanding the science behind Britney's breakdown gives us the power to prevent future tragedies. We can identify at-risk individuals before they reach their breaking point. We can develop targeted interventions based on genetic profiles. We can create environments that work with our biology instead of against it. The girl who walked into that salon in 2007 was carrying more than just the weight of fame. She was carrying genetic instructions written over thousands of generations, activated by an environment human evolution never prepared us for. The cameras, the pressure, the complete loss of privacy. These are evolutionary novel stressors our genes don't know how to handle. What happened to Britney Spears wasn't just a story. It was science unfolding in real time. And now, finally, after years of research, artificial intelligence, and genetic breakthroughs, we can read the code. We can see the invisible forces that drove one of the world's biggest stars to that desperate moment. And maybe, just maybe, we can make sure it never happens again. The truth is more profound than any tabloid headline could ever capture. In that hair salon, surrounded by shocked onlookers and soon-to-be viral photographs, Britney Spears became an unwitting pioneer in our understanding of human genetics and trauma. Her breakdown was our breakthrough. Her pain became our scientific progress. And in the end, her story might save countless others from walking the same devastating path.